For some work, it's useful to be able to convert between coordinate systems. And so we are going to convert the equation r equals 4 times the secant of theta to the Cartesian coordinate system. Remember that we have conversions. They are x equals r times the cosine of theta, y equals r times the sine of theta, x squared plus y squared is equal to r squared, and the tangent of y over x is equal to theta. We have here r equals 4 times the secant of theta. I'd like to be able to express what I see in the equation in terms of some of these conversions. And so it seems to me that if we multiply both sides by the cosine of theta, then we're going to end up with 4 equals r times the cosine of theta, excuse me. Well, that means that 4 is equal to x, and we have here a vertical line. Next up, r squared times the sine of 2 theta is equal to 1. Still keeping in mind these conversions, I don't see anything about a 2 theta here, but I know we have a double angle identity for the sine function. The sine of 2 theta can be expressed as 2 times the sine of theta times the cosine of theta. And so rewriting our equation, we have that times r squared is equal to 1. And then again, we have something that involves an r cosine theta and an r sine theta. And so I'm going to divide by 2 and express this as r times the sine of theta times r times the cosine of theta is equal to 1/2. So we get that xy is equal to 1/2. And folks, please, when you're converting, don't do like part of it in terms of x and y and then leave part of it in terms of r and theta. Each equation should contain only r and theta or only x and y. Well, finally, this is an equation that we can actually solve for y, and so we're going to do that, and we get y equals 1 over 2 times x. That happens to be a hyperbola. Now we're going to go the other way and convert to the polar coordinate system. We again have our conversion factors. Our equation here is going to be 4y squared is equal to x. Now, since y is equal to r sine theta, we're going to have 4r squared sine squared of theta is equal to, and then on the right hand side we have x, which is r times the cosine of theta. A couple of things to note here. Solve for r if possible, and we can simplify by dividing by r if needed. Now, I wasn't there when the math people had the meeting that said that they could divide by r, but it's true. So we're going to, since I do see an r squared on the left and an r on the right, I'm going to go ahead and do that. And I'm going to divide by 4 right now. And so we have r sine squared of theta is equal to 1/4 times the cosine of theta. And I'm going to solve for r by multiplying both sides by the sine squared. That's going to give me r is equal to, if I said multiply, I meant divide. And I'll express it as the cosecant squared of theta. So we get r equals 1/4 cosecant squared of theta times the cosine of theta. And this actually, we can rewrite this because with our cosecant squared, that means we have 2 factors of sine in the denominator. Putting one of those in a denominator underneath the cosine will give us that r is equal to 1/4 times the cosecant of theta times the cotangent of theta. And it may look like, well, this isn't much simpler. We have 2 trig functions. Well, that's true, but we also don't have an exponent at all. But more to the point for me, the cosecant of theta times the cotangent of theta is actually the derivative of the negative cosecant of theta. So this is actually a form of an equation that kind of looks familiar in terms of calculus.